I'm Tony Chan Carusone, Chief Technology Officer of Alpahwave Semi. In 2026, we'll see some elements of the AI infrastructure story flipped on their heads. We spent the last few years obsessing over flops, parameters, and chip counts, but if you zoom out to the system level, a different picture is emerging. So my three predictions for 2026 are simple. Power becomes the bottleneck. AI clusters are stretching across cities, and chiplets finally get boring, which is a big positive change. So first, power is the main bottleneck, not chips. We're already seeing it, but in 2026 it becomes undeniable. The story is watts, not flops. A gating factor for new AI capacity is, can I deliver enough megawatts when and where it needs to go? Every part of the stack gets reevaluated through that lens. How many picojoules per bit does my fabric consume? How many watts per rack do I burn just moving data around? How much more useful work can I get done per watt year? In 2026, the winning designs are going to deliver the most useful AI work per joule. Second prediction. In 2026, AI scaling is going beyond just scale up and scale out. The hottest AI clusters aren't just bigger, they're actually geographically stretched. We're thinking about AI systems not as a single building anymore, but as a metro scale cluster. That means system design starts with the network topology, metro, data center, and rack level connectivity first, and then work inward to where the chips and the memory sit. The interconnect fabric is like a portfolio, almost like a menu you can choose from. Short reach passive copper, active electrical cables, pluggables, co-packaged or near packaged optics, all over different reaches, each offering different cost, power, density, latency, performance trade-offs. 400 gig class signaling may have multiple flavors coexisting alongside high volume, well understood 200 gig class signaling. The diversity is a feature and it's not a bug. It's what lets operators develop networks for tailored solutions that are best fit for their needs as they stitch together clusters across large geographical spaces. Third and final prediction. Chiplets are becoming boring business as usual. And that's why they really matter. For years, chiplets have been a fun item on every roadmap slide. In 2026, they become mundane, and that's a big shift. By 2026, chiplets are no longer exotic science projects. They become just another normal part of the semiconductor supply chain. If you're building a serious accelerator, a switch, or even an optical engine, the default assumption is going to be, of course, it's chiplet-based. The interesting question then becomes, which chiplets do you pick? And how do you integrate compute, I/O, memory, even optical chiplets from an increasingly rich ecosystem? That boring maturity is what's going to unlock faster innovation at the system level. You don't need a brand new monolithic die to create a new SKU or a new AI system architecture. You recombine building blocks. So that's my view of 2026. We stop chasing raw flops, start optimizing watts. We stop thinking in single data centers and start thinking about cities. And we stop treating chiplets as science projects and start treating them as building blocks. With all that, the next generation of AI infrastructure is going to look very different from what we're building today and much more powerful because of it.